Okay. So next, the next standard limit is limit x tends to 0, x power n minus a power n by x minus a is equals to n into a power n minus 1. So instead of just reading it, you just see the standard limit, then it will store in your mind. So n into a power n minus 1. So how x power n minus a power n by x minus a, if you assume this is a function, and in this function if x value is tending towards 0, then this function is approaches to n into a power n minus 1. That means it is a limit. How this value is n into a power n minus 1. Okay, so to do this or to prove this, it's very small thing. The only one thing is you must know what is this x power n minus a power n. I will tell you the proof of this also. Okay, if I write here, you feel like I'm going to encouraging or memorizing you to remember that formula. No, we have the specification. So before that, if I substitute x value 0 here, if I substitute x value 0, what is going to happen? It's going to become 0 or n minus a. I'm so sorry. X tends to a. I'm sorry. Okay. This is x tends to a. Okay. If I substitute x as a power n minus a power n by, here x value is a minus a. So a power n, a power n. So actually we should not say a power n, we should say a exponent n, a exponent n. So this is going to become 0 by a minus a is also 0. So 0 by 0, which is actually once again an indeterminate form. So wherever the indeterminate will come, that's where the role of a limits is going to be, the picture of limits picture is going to come out. It's not the, for example, if you substitute and get the limit, that's where the limits concept is not really applying. Okay, where the limit concept will come, wherever the function is tending towards, or the function value is indeterminate form, or whenever the function is giving an indeterminate form, that's where the limits concept will come into the picture. Okay, so this is going to give an indeterminate form, so therefore we need to apply different techniques. Either you can use rationalization, or you can use factorization, or you can do a little bit of simplification, and we'll find the value of the limit of that function. So now same as here we cannot go for a rationalization because it seems to be like a rational number only. So rationalization is not something a useful technique here, but a factorization is something which is going to help us here. So we are going to find the factorization, or we are going to do the factorization for x power n minus a power n. So I need your kind attention and best attention, in fact, to factorize this x power n minus a power n, x power n minus a power n. Right, for example, see here n value is a natural number, n is a natural number here. Okay, first, for example, if n value is natural, means either it can be an even number or it can be a odd number. Okay, for example, let's try to take n value as 2. I would like to take 2. So why you are not taking 1? For example, if I take 1, okay, I'll tell you that little later. N value is 2. If I take n value 2, you are going to get x power 2 minus a power 2. See, what is my intention? My intention is to factorize x power n minus a power n. I wanted, what do you mean by factorization? That means I need to express this as, this is going to divide by what? What do you mean by factor? A factor is something which is going to divide this and gives the remainder 0. So which value, which algebraic expression will divide this function and gives the remainder 0? So I am going to find that. That is what we call it as factorization. So x power 2 minus a power 2. And is it not looking like a square minus b square? And if something is in the form of a square minus b square, we can write it as what? A minus, this is an identity, a minus b of a plus b. Can we write like that? We can write. So therefore, in the same fashion, we can write x square minus a square as what? X minus a into x plus a. Can you tell me what do you mean by this? So actually the meaning is x square minus a square can be written as x minus a into x plus a. Can I write into x minus a into x plus a? What do you mean by this? X square minus a square, these two are factors of this one. X minus a is also factor, x plus a is also a factor. What do you mean by factor? That means if I divide x square minus a square with x minus a, it gives the remainder 0 and it gives the quotient x plus a. If I divide x square minus a square with x minus a, okay, it gives remainder 0. If I divide x square minus a square with x minus a, it gives the remainder 0 and gives x plus a as a quotient. Okay, if you don't understand, you can understand from a simple arithmetic number. For example, I am writing 12 as 3 into 4. What do you mean by 3 into 4? If I divide, 3 is a factor, correct? 4 is also factor. What do you mean by factor? If I divide 12 with 3, remainder is 0. Okay, so 3 is also factor. So let's divide this 12 with 3. So what are you getting? You are getting 3 4s are 12 and you are getting remainder 0. What is this for? Quotient. See, but 3 is also factor, 4 is also factor. What do you mean by 4 is factor? If I divide 12 with 4, then 3 is a quotient. So, but your remainder is 0. The one thing is very clear, 3 and 4 both are factors. Okay, so if I divide, so this is 12 now. This is 12 and let's assume this is 3 and this is 4. So x3 divides 12. Okay, 4 also divides 3. But if I divides with 3, 4 is a quotient. If I divides with 4, 3 is a quotient. So this is also factor. Here I am saying it is a factor. Factor means x minus a divides x square minus a square. Okay. See, what I am going to do is I am going to simplify x power n minus a power n. A power n. I am factorizing it. What do you mean by factor? What are the numbers? Which is the best? Which is the factor for x power n minus a power n? Now, so one thing is very clear. Okay. Shall I write this as once again? Shall I write this? In this case, can I write this as x minus a is a factor of x square minus a square? Okay, so we are going to use this x minus a. Okay, can I say x minus a is a factor of x square minus a square? So can I write x square minus a square divides x minus a, or can I say x square minus a square? X minus a is a factor. Factor of what? X power 2 minus a power 2. Next, see, I am taking one even number and one odd number, and through that we can differentiate, we can find one fact, we can find one observation. Now I am taking n value as 3. If I take n value 3, what are you going to get? You will get x cube minus a cube. So x cube minus a cube. Is it not looking like, okay, let's keep this one, a cube minus b cube. Let's write this is a cube minus b cube. So a cube minus b cube. What is the factorial? I mean, what is the identity? How can you write this as a minus b of a square plus ab plus b square? This is how we can write it. How can you write a cube minus b cube? A cube minus b cube is equals to a minus b of a square plus ab plus b square. That's how we can write it. Now, what do you mean by this? I can write x cube minus a cube as x minus a into x square plus, here a means x into a plus b means a square. Okay, did you understand any difference here? X square minus a square, factor is x minus a. Even x cube minus a cube, factor is what? X minus a. Even if n value is even, x minus a is factor, n value is odd, still x minus a is factor. This is true for any n. Any n means even n can be even, n can be odd. Definitely x power 2, I mean x power n minus a power n, factor is always x minus a. Okay, if you want, let us go for n value 4 once again for more understanding. We are going to get x power 4 minus a power 4. So this is, can I write this as x square minus a square into x square plus a square, and this can be written as x square, I'm sorry, x minus a into x plus a into x square plus a square. What is one thing common in this n is equal to 2 case, x minus a is factor, n is equal to 3 case, x minus a is factor, n is equal to 4 case, also you are going to get x minus a as a factor. Now even n is equal to 5, even you take n is equal to 5, still we can write x minus a is going to be a factor. That is the point I just wanted to make it clear. So what is one thing common? Even n is even or odd, x minus a is a definite factor of x power n minus a power n. Okay, so x power n minus a power n. Okay, whose factor is what? X minus a. That is a definite factor. But what about quotient? Okay, to get a quotient, see, directly you can divide this one with this, but it's going to be difficult. So you can divide it, actually you can do it. Okay, so what are we going to get is, okay, we will get something like this: x power n minus 1 into a power 0 plus x power n minus 2. Okay, shall I tell you the technique to remember it? Of course I will not encourage you to remember this. Actually, if you do the division with x power n minus a power n, if you do the division of x power n minus a power n with x minus a, this is what you will get it. Okay, yeah, if you want you can do the division. The people who are very comfortable in doing the division, okay, they can go for it. Polynomials, learn this: x power n minus 1. Okay, next plus you write x power n minus 2. Next you write x power n minus 3. Next, okay, just for your understanding I am writing these many terms, not required to write this: x power n minus 4. Okay, x power n minus 5, and so on. And lastly we are going to get with, okay, x power, okay, here if you observe what is you are getting n minus 1. Okay, and lastly you are going to get, here do you have any a term here? No, there is no a term. Now I am going to replace here with a power 0, a power 0. Here you are going to get a power 1. Here you are going to get a power 2. Here you are going to get a power 3. I take here we'll get a power 4. And see what's happening here: the x exponents are decreasing: n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, and a exponents are started from 0 and it is increasing, a power 0. Okay, so actually due to the short of battery, it did not record the entire session. I was already delivered, but it did not record, so I need to explain that once again, that part. So this is what I'm been explaining there: x power n minus a power n factorization. Okay, if you observe that n value even or odd, one thing is very clear: it is definitely divides with x minus a. So therefore x minus a, if you divide x power n minus a power n with x minus a, okay, this is what the question will be. So what is that? X power n minus 1 plus x power n minus 2 plus x power n minus 3 plus x power n minus 4. Okay, I am writing so many terms only to get the good understanding. So it will start with n minus 1 and it will end with 0. And so this is what, it's very simple to remember. It should start with x power n minus 1 and it will decrease, x exponent will decrease, x power n minus 1, n minus 2, n minus 3, n minus 4, and it ends with x power 0. So it starts with n minus 1, ends with 0. So this is how x exponent, actually this is these things you can understand from the binomial expression also. Now see this one, I did not write a. Okay, now it will start with a power 0, next a power 1, okay, a power 2, and this is a power 3. So here a exponents are increasing. It started with 0, 1, 2, 3, and it goes on up to, see, x power. For example, if you understand in a reverse way, x power 0, before this what it could be, x power 1, x power 2, x power 3, x power 4, x power n minus 4, x power n minus 3, x power n minus 2, x power n minus 1. So it started with 0 and it goes up to n minus 1. Same way, a power 0, it started with a exponent 0, a power 0, a power 1, a power 2, and how long it goes on? It goes up to a power n minus 1. If you just look at with the clear observation, you will get that find. You will get that spark point in that. You will get that important point. See, what I am trying to say is x power n minus 1. It started with n minus 1 and it ended with 0. A exponent started with 0, it ends with n minus 1. And I mean, these two are going to be 1x. And one more thing, here x values, x exponents are decreasing. Okay, so right. So now we found the factorization of x power n minus a power n. So what is the value of it? What we got? X minus a of x power n minus 1 plus x power n minus 2, x power n minus 3, and so on, x power. So n value is decreasing, it will decrease up to 0. Next, a value will increase. A value will increase, so it starts with a power 0, a power 1, this is a power 2, and this is up to. So it started with x power n minus 1 and it ended with x power 0. So a is started with a power 0, it will end with a power n minus 1. So this is the factorial form of x power n minus a power n. This is how we can write x power n minus a power n value. So this is what I am going to write in place of x power n minus a power n. So let me replace that. Limit extends to a. So in place of x power n minus a power n, I am writing x minus a of, see, x power n minus 1. I am just writing x power n minus 1 because a power 0 value is 1 plus x power n minus 2 into, this is a power 1, x power n minus 3 into, this is a power 2, and it ended with x power 0 1 into a power n minus 1. So this is the expansion of x power n minus a power n by, so in place of x power n minus n, a power n, x power n minus a power n place, I am writing this one. Okay, so let's just separate this position. Right. So by x minus a. Now x minus a and x minus a gets cancelled. So limit x tends to a. This is what? X power n minus 1 plus x power n minus 2 of a power 1. We can write as a, and x power n minus 3 into a power 2 dash 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 a power n minus 1. So this is what we'll get it. And now okay, so now we'll try to, because we simplified this format as we are getting an indeterminate form. To avoid that indeterminate form, we are doing a factorization and we got this form. So now let's try to substitute x value this at this expression. Okay, so if I substitute x value as a, so you will get something like a power n minus 1, a power n minus 1 plus, see, this is a power n minus 2 into a plus a power n minus 3 into a power 2 plus dash 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 a power n minus 1. Now this value is a power n minus 1. So this is a power 1 n minus 2. Bases are same and they are multiplying. So therefore the exponents will be added. N minus 2 plus 1. So it will become a power n minus 1. So in this place also we are going to get a power, bases are same and they are multiplying. Therefore the powers will be, exponents will be added. So n minus 3 plus 2. N minus 3 plus 2 is n minus 1. So a power n minus 1. And lastly we also have a power n minus 1. So this is what we have it. So but how many a power n minus 1 are added here? This is also a power n minus 1, this is also a power n minus 1, this is also a power n minus 1, even the last term is also a power n minus 1. But the point is how many a power n minus 1s are there here. If you observe closely, it will be like this. See, it started with x power n minus 1 and ended with 0. So what I mean, x terms are started with what? X power n minus 1 and it ends with 0. So n minus 1 to 0. Or can I write 0 to n minus 1? I wanted to find 0 to n minus 1. How many terms were there? Okay. See, because this is also, it is started with x power n minus 1 and x power 0. Okay. X power 0. X power 0 means 1. So how many terms will exist from x power n minus 1 to x power 0? That means 0 to n minus 1. How many terms? So to know that, for example, let us assume 0 to 1. How many numbers are there? 0 and 1. Two numbers are there. Okay. So I would like to write this 2 as up to 1 plus 1. Can I write 1 plus 1? Now 0 to 2. How many numbers will be there? So it is actually 0, 1 and 2. So I would like to express this sum 3 with this last number. So 2 plus 1. So 1 is a constant. For example, 0 to 5. How much it is? We can write 6. So how can you write this? 5 plus 1. Same way, 0 to n numbers. Okay, 0 to n. How many numbers? Okay, which are n plus 1 numbers. Same way, 0 to n minus 1 numbers. How many 0 to n minus 1 numbers are there? N minus 1 plus 1. So this plus 1 and minus 1 gets cancelled. Therefore, there are 10 numbers. How many numbers will exist? Here, n times it is going to be multiplied. I mean, a power n minus 1, a power n minus 1, there are n times. So therefore, you can write this as n into a power n minus 1. So there are n a power n minus 1 terms are there. Okay. If you want to understand this one, for example 3, how many 3's are there? 1 times 3 is there, so 1 into 3. For example, if I write 2 times 3, then it is 2 into 3. If I write 3 times, then it is 3 into 3. If I write 4 times 3, then it is 4 into 3. If I write n times 3, if I write n times 3, then it is n times 3. So therefore here a power n minus 1 is also added n times. Therefore n into a power n minus 1. And that is what we need to find it. So this is the result. I mean, this is the limit of x power n minus a power n by x minus a when x tends to a. So what do you mean by this? This function will approaches n into a power n minus 1 value when x is tends to a. So this is the explanation and proof of x power n minus a power n.